Good morning, this is your Stat Sensei, Mr. Spensei, and this is classical probability, and we're reviewing contingency tables from Unit 2. Okay, so here we go. The table below shows a list of computer chip manufacturers and contains information about their defect rates. First off, when I see a table like this and it's not completed, I need to sum them up. Well, these probabilities all need to sum up to one whole, so I can go ahead and drop this in there without doing any work. I know that that should be 1. So let's check this all out. Let's add up this column, 0.04 plus 0.03 plus 0.035. Oops, I didn't hit plus. That's not good. 0.04 plus 0.03 plus 0.035, and I get 0.105. Now, let's add this column up. 0.49 plus 0.26 plus 0.145 equals 0.895. Let's check my workout because I should be able to add these two numbers and add up to 1. So 0.105 plus 0.895, that adds up to 1. I did that correctly. So then I need to add these numbers up, and I go 0.04 plus 0.49, and I get 0.53. And 0.03 plus 0.26 is 0.29. And then 0.035 plus 0.145 is 0.18. Again, let's check our workout because these numbers should add up to 1. So 0.53 plus 0.29 plus 0.18 adds up to one whole. Looks like I added everything up correctly. That's good. Okay, I want to talk to you real quickly about these. The ones that I'm circling right here, these are known as joint probabilities because it's defective and from Intel, defective and from Acer. Notice I'm using the word and, all right? Because there are two things involved, defective and AMD, not defective in Intel, not defective in Acer. So they're saying and. The only thing I know about this probability out here is it came directly from this is defective. I know this is defective. I know this is not defective. I know this is from Intel. I know this is Acer and this is AMD. So the ones I just highlighted, we don't know whether they're defective or not. We just know they're from Intel. We don't know if these are where these are from. We just know they're defective. So marginal only deals with one variable. Joint deals with two variables. So the marginals are the ones that I highlighted in yellow. Okay. Somewhere over here, I have a better looking view of this. Here it is. Okay, so I added those up, and that was a work done. So our first question is, what is the probability that a randomly selected chip comes from Acer? Well, I can just read that off the table, and it's 0.29 over 1. We always want to write it as a fraction. In this case, it's 0.29. The next one, what's the probability it's defective? Well, 0.105 over 1, which is just 0.105, is not defective and does not come from Intel. So let's look at that. Not defective. So not defective means we're looking at this column, but not from Intel means I have to look at where they intersect. So I'm going to have to add up these two and divide it by this. So 0.26 plus the 0.145, that's coming from those two, divided by, excuse me, it doesn't say given. I'm sorry about that. So I'm just looking at from one whole because it doesn't say the word given. Is not and is intersection. Well, this time we intersect at two spots, this and this, out of the whole. Next one is defective and comes from AMD. I hope it's not defective. I bought stock in them. So is defective or that's AMD, and is defective. Well, my intersection is 0.035, so 0.035 over 1, because again, it doesn't say given, so we're not dividing anything but from the total. When it doesn't say given, we're dividing by whatever the total amount is. Okay, letter E. What's the probability is defective or is not defective and is an Intel chip? Well, is not defective and is an Intel chip. There's my intersection. So 0.49 over 1. Again, and means intersection. All right, where the streets cross. Letter F. Given that a computer chip is an Intel chip, okay, so now we have the word given. And anytime it's given, remember it's always intersection over given. Given that it is an Intel chip, okay, well, that's 0.53. That's what we were given. This is what I was given, so this is going in the denominator. What's the probability the chip is defective? Well, where's my intersection? 0.04. So 0.04 over 0.53. The next one, given, so intersection over given, that a computer chip is defective. So we're caring about the defective ones. So my denominator is 0.105. What's the probability the chip came from Acer? So where does it cross? Oh, it crosses here. That's where the streets cross. So 0.03 divided by 0.105. And then finally down to the last one. Given that a chip is not defective, what's the probability the chip was not manufactured by Acer? So again, we're looking at intersection over given. This one's a little bit tricky, but given the chip is not defective, so we're looking at the not defective. What's the probability the chip was not manufactured by Acer? That means we can't include Acer. We can only include AMD and Intel. So my denominator is 0.895 because that's what I was given. But my numerator is going to be these two added together. All right. I hope this helped, and I sure look forward to seeing you on the next one. Thanks for watching.